Hello friends, Jermaine here and welcome to this video. We'll be looking at the Flutter Bloc package, which provides a set of widgets built on top of the Bloc library. It's pretty much one of the top recommended approaches to state management, and it's a great option for separating presentation from business logic. You can use this package by running flutter pub add Flutter Bloc. We should add the latest version. And once we've installed it, let's go ahead and run the counter example in this bootstrapped Flutter application. So I'll just hit F5. Okay, and we've got our counter example here. When we look at the logic, relies on set state. So let's see how we can convert this into using the Flutter Bloc approach. Under the lib directory, I'm going to create a new file, which will go under counter/bloc. I'll call it CounterBloc. .dart. This file will be responsible for holding the business logic related to the counter and its current value. So to create our block, we'll first extend block and be sure to import the Flutter Bloc package. Block is a generic type that takes two type parameters. So one is an event and two is the state. So in our use case, we'll have a counter event, which will be dispatched, and that'll be used to update our state, which will be an integer. I'll create a new file under block called counter event. I'll define the counter event class and we'll extend by creating a counter incremented and a counter decremented event. These will be used to update our counter value. And then over here in our counter block, we'll be sure to import our counter event. In our counter block, let's define our constructor, also instantiate the parent constructor with the initial state value. I'll go ahead and save this file, and then let's export these two files. And the counter, I'll create a new file called counter.dart, and I'll export both files, which means in our main.dart, I'll import that file over here like so. And then in order to use our block, we need to instantiate a BlocProvider, which is a widget that will allow our block to be accessible by its children widgets. So we'll get rid of all of that. We'll cut this for now, and then we'll declare a BlocProvider. Be sure to import the Flutter Bloc library. This takes in a create function, exposing the current build context, but we don't care about that. We just want to instantiate our counter block like so. And then over here, we specify the child group of widgets we want this block to be available to, which is effectively our counter app. Let us read our state value from our counter block into our widget. So over here, we've got underscore counter, which is from our stateful widget. So let's retrieve that from our counter block. We'll create a variable, and over here we'll do context.read, and then we'll read from our counter block, and then we'll do .state, which means we can now come down here, and instead of counter, we can inject our state. And then what we want to do is update our state value when we increment counter. We'll go back to our counter block, and we need to listen for a counter event. And then in the callback, we get a reference to the event, and then we get an event emitter, which is what we use to update our state. We'll have a conditional check for two types of events. For the counter incremented event, we will emit our current state, and then we'll add 1. For our counter decremented event, we will subtract 1, like so. So if we come back to our main function, in our increment counter, we'll get rid of all of this. And then in here, we can do context.read. So over here, we want to add our counter incremented event like so, which should go ahead and update our state, which should update the UI. Let's restart. Okay, so let's test it out. I'll hit increment. Okay, we don't see anything happening, which is because we're using the read method. So this read method would read the current state at the time this method was invoked, and it's not going to listen for any updates to rebuild our widget tree. So in order to listen for updates to our state, we need to use the watch method. So if I save that and I hit plus, now we see the updates being applied because watch detects the state for changes, and then it rebuilds the full widget tree, applying the updated state value. Let's add the decrement behavior. I'll come down here to our floating action button, and then I'll wrap this in a column, and then add another floating action button. Let's go ahead and define our decrement counter method, which is gonna invoke the counter decremented event. Let's get rid of this counter, and I'll save this. So if I decrement, it reduces the value, and when I increment, it increases the value. And just to move it to the bottom right, I'll set the main axis alignment. Now we got our block fully functional. Even though watch allows us to listen for state changes, every time our state changes, we are rebuilding this whole tree of widgets, even though the actual scope of changes is this text widget here. For this basic example, it's not too much of an issue, but if we've got more widgets that are being rendered, it could potentially become a performance issue. So just to show what I mean, I'm going to add this print statement over here, and let's open our debug console so that whenever we make changes, we see that the full widget tree is being rebuilt. To save us from doing that, the Flutter Bloc package gives us a block builder, which allows us to rebuild only the widgets that will receive our updated state. So to use our block builder, we'll declare it. Builder takes two type parameters, one which is our CounterBloc, and then the type of state. We specify a builder which exposes the current build context and our state, and then in here return our updated text with the current state value. I'm going to add another print statement here just to confirm that we are only rebuilding this widget, and I am going to get rid of that. Let me restart the whole app, and let's try that again. Okay, there we go. So now we're only rebuilding this widget thanks to our block builder. Alright, so just to recap, if there are a lot of widgets being rendered, you'd be better off using a block builder to rebuild only the widget that needs to be rebuilt to receive the latest state update. Or you can use a context.read or context.watch if you wish to rebuild the full tree of widgets in its current build function. We're going to go to another example, a more complex one, which will be a fictitious store. We're going to be working with the FakeStore API, which allows us to hit this endpoint over here and gives us a list of products. And we're going to create a cart whereby we're able to add products to the cart and remove products from the cart. Under the lib directory, I'll add a new folder called store. And then because I've installed the block extension by Felix himself, I am able to right click on store and select new block. And then this block will be called store, which means in the store, we get our block directory, and then we get these files created for us. I'll also export these files by creating a store.dart and adding the relevant exports. And we're getting these red lines because our store event is using a part of directive. And just get rid of these and then replace with these imports. And then over here, we just get rid of those. And in store state, we'll just have store state with our store import. And then on the StoreBloc, we will instantiate store state. In order to update our store state, we'll need to be dispatching the relevant store events, which will be these events over here. And let's be sure to add our const constructor here. The store products requested event will be the event that will be initially dispatched, which we'll use to make our call to our API endpoint to retrieve the products from the FakeStore API. This event will be emitted once we add a product to our cart, and then this event will be emitted once we remove a product from our cart. Each of these takes a cart ID because we're going to be updating a set of IDs. So we'll save that, and then let's look at our store state. we'll be updating these fields, whereby the products field will contain a list of product types. Each product type will be a data class representing each of the list items from our FakeStore API response. Product status will be an enum containing the current state of our request that will be made to retrieve our products. And cart IDs will be a set of product ID that is marked as part of our shopping cart. We'll go ahead and define our store request enum in here, which will contain these request states. And before we define our product model, let's create our constructor. And then in here, we'll define our fields. Products by default will be an empty list. Product status will be set to unknown by default, and cart IDs will be an empty set. Also, because our state is immutable, we'll define a copywith method, which is responsible for creating a new store state object, which will accept the updated state fields, or it'll persist the previous state values if they haven't changed. So I'll go ahead and save this, and then let's create our product model. Under store, I'll create a new file under models, and then I'll call it product. We'll have our product class and our product constructor, which will only pull the ID, title, and image from our FakeStore API response. And I'll define the relevant fields here. Okay, let's save this file and add it to our list of exports. Okay, so that is good. Before we modify our block, we need a way of making our API request to our FakeStore endpoint, which is what a HTTP client will do for us. So let's open the terminal, and then I'm going to add the DO package for making HTTP requests. And once that's added, under store, I'll create a new file under the repository directory, and then we'll call it store repository.dart. A repository is effectively responsible for talking to our endpoint and transforming the results, which will be used in our block. I'll have the relevant imports, instantiate our store repository class, define my DO client, which takes in a base options object. We'll specify the base URL, which is our FakeStore API endpoint. This store repository only takes one method called getProducts. And then in here, we'll make the API call to retrieve our products, and then we'll transform the response to our list of product types. So if we cast response data as list, then we'll map over those results. For each of these results, we'll extract the ID from our map, the title, and the image. Now that we've got our repository, we can return to our StoreBloc and then define our store repository here, which will instantiate store repository. As well as listening to the generic store event and having an if condition, we can also listen to the actual class store products requested, for instance, and then we can define our callback over here. This takes the following arguments, which maps onto these two. So I can have that in here. And in here, we can call our API and update our state from the response. I'll have my try-catch block. And then before I make the call, let's emit a state change. In particular, our product status, we'll set that to request in progress. This is useful because we'll be able to show a spinning icon while the request is happening. And then let's make our actual request. And then once we've received our response, we'll update our product status and then our list of products. And then if for some reason this fails, we will set our product status to request failure. All right. So in order to use this block, let's create our view to consume it. And the store, I'll create a new file. We'll have it view and we'll call it storeapp.dart. In here, we'll instantiate a stateless widget, call it storeapp, and be sure to import Flutter material. And then I'll instantiate a stateful widget called storeapp.view. And in here, I'll return a material app widget with our BlocProvider containing our StoreBloc. Let's import the relevant files and let's like so. We'll define a scaffold widget with an app bar and a center widget in the body. The child here will be a block builder. In here, we're going to have a couple of if checks based on our product status. All right, so based on our product status, we'll return the relevant widgets. So if our request is in progress, we'll return a circular progress indicator. Should the request fail for whatever reason, we'll render a column widget with a message that says problem loading products with a button to try again. And then once we click try again, we will go on ahead and dispatch the store products requested event. If product status is unknown, then similarly, we will render a column with a text that says no products to view, and then we'll have a button, which upon clicking that, will also emit the store products requested event. And if none of these if conditions are met, then that means the request was successful, at which point for now I'll just return success. So let's go ahead and use this widget. I'll be sure to export it, and then in our main.dart we'll import our store, and then we'll have our store app like so. And then I'll stop and start the app again. So over here we got that, no products to view. So what happens when I click load products? We see the circular progress indicator briefly, and then we get this message that says problem loading products. So the reason why it fails is because we're running this as a macOS application. We need to update the entitlements file to allow the app to make network requests. So according to the Flutter docs, we should be able to, under macOS, and then runner, we'll open our debug profile entitlements file and then enable the network client, set that to true, and also do the same under release.entitlements. And then when we start the app again, and then I click on load products, then it proceeds to make the call, and now we're getting a success over here. Okay, so let's render our products to the screen now that we're getting a success. So let's render this out by using a grid view builder. Set our item count and then our item builder. It's where we define what each item looks like. I'll create a variable to represent our current product. And then let's render a card with a column. The first child will be a flexible widget, which will display our image. And let's save this and check. Okay, so we're getting the images returned now. Looks like some of these images, takes a while to load. I'll also specify a key. So the key here is the product ID. And let's add some spacing and set the title, which I'll have in an expanded widget, and save that. Okay. And then we'll render our outline button. This will take in a child. That'll be a row. This row will have the following widgets in here as such. That looks like that. And let's just add a little bit of padding. Okay, that looks good. Because this button is going to be used to toggle the add to cart and remove from cart functionality, let's go ahead and define both methods. So over here, we can define both methods to add and remove from cart. And then in our add to cart, we'll add the store products added to cart event with the cart ID. And then remove from cart, we'll dispatch the store products removed from cart event with the cart ID. And then in order for these to work, we need to update our block to respond to these events. So over here, we'll add 2 new event listeners, and then this will be our store products added to cart, and then our store products removed from cart. And then we'll define these methods over here. So when our products are added to the cart, we will do a state.copyWith, and then under our cart IDs, we'll grab our current list of IDs, and then we'll add our new cart ID from the event object. And then to handle our products removed from cart, similarly, we'll create a new set from our current list of cart IDs while removing the cart ID which was passed in the store products removed from cart event. So saving that. So let's come back to our store app, and then in our UI, we need to change what this looks like. So in order to do this, we'll create another variable here called inCart, and then we'll do state.cartids.contains product ID. And then from that, we will render the relevant widget children. We need to add the methods to add to our cart and remove from our cart. So we're going to check if it's in the cart, then we will invoke the remove from cart with the product ID, or else if it's not in the cart already, then we'll invoke the method to add our current product to the cart. So I'll save that and let's see. Okay, there we go. So that's been added to the cart. And now let's display a text that says remove from cart. We'll render these widgets, which is the remove shopping cart icon with this text. So that looks good. I should be able to click that and then it's removed from the cart, which resets to this. And then when I click that, it's added to the cart again. Let's change this background color of this button, and I'll add this button style to this outlined button. And then the background color, also if it's in the cart, then we'll give it a gray color, or else we'll set it to null. So let's save that, and now it looks like that. Next, we're going to display a floating action button at the bottom right to view the products that we have in our cart on another screen. Let's define our floating action button. Okay, and the tooltip for this floating action button will be view cart with the shopping cart icon. So looking like that. When that is pressed, we'll invoke the view cart method. And then over here, we can define that. So in order to launch our view cart screen, let's create this widget. Under view, I'll have cart screen. And make sure I got the relevant imports. And then we'll do a navigator.push. And then for our route builder, we'll use a page route builder. We'll just return our cart screen. And let's export this cart screen. Let's actually add our scaffold. And once we save that, yep, that is good. I want to add a page transition because I want the view cart screen to slide up. To do that, we need to define our transitions builder, and then we'll use a slide transition. And then in our position, we'll have this tween, which is based on these offset values. And then child of this slide transition will be our child widget over here, which is a pointer to this one. So if we try that now it slides in from the bottom to the top. Let's load our products. And let's add some items to the cart. And then we go to our view cart and let's load the items we have in our cart. So in our cart screen, I'll create a variable cart products. And what we can do is we can actually use another method, select. Now this works similarly to watch, but then it returns a calculated result. We'll specify our block and then we'll specify what we are returning. So this will be a list of product types. And then in here, we have a reference to our block. So we do block.state.products. And we want to pick the products where the cart IDs contain this product's ID. And then we'll return a list. So saving this, we get this error, provider not found exception, which is because in our store app, when we launch this new screen, our cart screen doesn't have access to the BlocProvider instantiated over here. So in order to resolve that, what we need to do is to pass our block with this slide transition to make it available to our cart screen. So if we have this in a center, and then I will change this to a BlocProvider.value widget, and then our value would be our StoreBloc, like so. And then we'll have to hot restart, load some products, add some to the cart, then view our cart, and then no exceptions. So if we come to our cart screen, and then in our body, we log out the length of cart products, then we get 3 over here. So which means that this filtering is working, because when we come back out, we added exactly 3 items to the cart. If I remove this from the cart and we view our cart, now it shows 2. So that works well. And in terms of what we're going to render, I'm just going to be lazy and render this grid view builder, widget. So I'll copy this and paste that here and tidy up. So instead of state products, we want our cart products. I'll make the same change here, and then we don't need this since it is already in our cart. So we can simplify this a bit more like so, and then simplify here as well. In fact, over here, I'll do context.read StoreBloc, and then we'll add a new event, which is our store products removed from cart, like so. And then over here, we'll remove these. So that looks about right. Let's see what we got. There we go. If I click remove from cart, this should disappear. And then also I click that, that should remove from cart. And when we go back, none of these items should be added to the cart since we've removed all of it. Let's display a message when we have no items currently in our cart. And let's do that over here by defining a variable, call it as empty cart. I'll do another context select, and then we'll return a boolean in this case. So now we'll check our cart IDs, and we want to know whether it's empty or not. And then in our body, we'll check if the cart is empty. Then we'll render a center widget with a column with a message that says your cart is empty, and an outline button with a text that says add products. Upon pressing on it, we'll pop the current screen. If the cart is not empty, then we'll proceed to rendering our grid view. So let's check that out. Save that. Okay, so we got this. Your cart is empty. When I click add products, it collapses and we're back to the screen. And when I add these items, they pop over here, and when all these items are removed, we see this message. One more thing to improve this experience, it would be good to have a badge that pops up here to let us know how many items we have in our cart. And we can do that by coming back to our store app, and then in our floating action button, I'll have this render in a stack widget. So we'll wrap with a column and change this to stack. Let's have our block builder, which will return a container if there are no items in our cart, or else it'll return a circle avatar in a positioned widget. So let's save that. Okay, so we see that here, there are 3 items in our cart. And to display the badge fully, we need to remove the clip behavior. Okay, so that looks good. So when we click on that, now we know the number of items we've got in our cart without counting. It's done that for us. When I open that and I remove some items, then it should update accordingly. All right, so we've got our working solution here, and we've based this on the block class, which relies on dispatching events that are used to update our store state. There is also a simpler base class that we can use called Cubit, whereby the difference is rather than dispatching events, which would invoke these methods, with a Cubit, we'll be able to invoke these methods directly. To do that, under block, I'll create a storeCubit.dart file. So to out my imports, declare a storeCubit, which will instantiate an empty store state. We'll instantiate our repository, which would be good to export. We'll define the methods to load our products, to add a product to the cart and remove a product from the cart. So with our load products, I can come over here to our store products requested event, and we'll be able to copy this and paste that in here and then save this. Let's test this out by creating a new view called Store App Cubit. I'll copy what's in Store App and paste in here. And the only difference is we'll replace all StoreBloc types with storeCubit. And then let's make sure we export our Cubit. And then for these methods, we want to invoke add to cart. And then we'll invoke remove from cart. Same here, we'll invoke load products. And then we'll do the same here. And let's save that. And then on the main.dart, we'll instantiate our store app Cubit, making sure that we export that. I'll rename this to store app Cubit because there's already a store app widget. And let's save that. Now save this file. Let's do a hot restart. This view cart button moved all the way here, which is not the effect we want. So let's wrap this in a positioned widget. And that should show up here. Let's copy this to our store app as well, so it's consistent. Okay, so back to our Cubit. If I click that, let me stop it. I will disable this for now, and let me run this again. And let's load our products. All right, we need to update our Cubit, which is going to rely on the same implementation in our StoreBloc. So when we add the cart, we do that, and we just drop that. And then when we remove from our cart, we'll emit state update. So let's try that again. Okay, now that looks good. And we see the changes here. And then let's sort out our view cart screen. And the view, I'll create a new widget called cart screen Cubit. I'll copy what I have here and paste in here. And let's replace StoreBloc with StoreCubit. And then over here, we will remove from cart. And that should be good. If we come back to our store app Cubit and we re-enable this, then cart screen Cubit, we need to rename this. Save that, export it. And then in our store app Cubit, we want our cart screen Cubit. So let's do a hot restart. Okay, let's check our cart. And then let's add some products to our cart. Okay, let's view our cart. All right, let's remove some products. There should be only one that's highlighted here. That's added to the cart, that one. And when I remove that from the cart, it's gone. Okay, that looks good. To recap, the main difference between using the block class versus the Cubit class is that Cubit classes allows us to invoke methods, whilst block classes allows us to emit events. For typical cases, Cubits are simpler to use, but then in the scenario where you need an event-based architecture with some better debugging, then you could go with blocks. And to demonstrate that, I will add a new file under lib, call it AppObserver.dart. In here, we'll extend BlocObserver. And what a BlocObserver does is, as it says here, it provides an interface for observing the behavior of block instances. So all the block objects that we've instantiated, we can observe that behavior from a single place. I'll override some of these methods. The onTransition event will be invoked when we invoke the add method with the event. Meanwhile, this will not be invoked if we're instantiating a Cubit. So to use this AppObserver, I saved that. Let me export it from an app.dart file to be consistent. And then over here in our main function, we'll do the following. We'll set the current BlocObserver instance to our AppObserver. So if I save this, and I do a hot restart. If I load products, we see our instance of store state, what the current state is and what the next state is. It's not very descriptive. And when we click around, it's effectively the same change event that we're given. However, if we replace this with store app and I restart the whole app and I load products, now we're given a bit more information. So not just the change event that is triggered, but the on event and on transition event is also triggered. So this way we get a bit more information, specifically the event that was added to the stream. So as we continue to interact with the UI, we get much more accurate details of our events that are emitted. Lastly, another useful widget Flutter Bloc provides is BlocListener widget. Then this takes a listener method. And what this allows us to do is to listen for state updates and then invoke any method we want. So the difference here is that listeners do not expect any return value. So the return is void. Whilst with block builders, there has to be a widget. So a typical application of this is in displaying snack bar messages. So for instance, in our listener, we can display a snack bar every time our shopping cart is updated. So if I save this, and then I update the shopping cart, we get this message. Click that, we get shopping cart updated. Let's restart the app and try again. So let's load our products. Okay, so we get shopping cart updated, which is not the expected behavior because it just invokes every time the state updates. What we want to do is to invoke the listener only when the shopping cart IDs are updated. So we can use the listen when method, whereby we check that our previous cart ID length does not equal to the current cart ID length. That way we know that our cart has been updated. So if I do a hot restart and load products, we should not see anything here. Okay, that's good. And when we add to our cart, now we see our cart message like so. And when we come over here in our view cart screen, when we remove, we also get the message displaying here. Okay, that's good. As well as having our block listener on its own, we are also able to combine our listener and our builder by instantiating a BlocConsumer instead. So I'll come to our Cubit example. Instead of BlocBuilder, I'll change this to BlocConsumer, which will take in our listen when and our listener methods. And just as we have a listener when, so we can also define a build when for block consumers as well as block builders to only rebuild our widgets when this condition is true. But over here, we don't need it, so I'll get rid of it. And let's confirm this works as well. If we come to our main.dart function and we instantiate StoreCubit, and let's restart. Okay. And we can add some items to the cart. Like so. We can view our cart. Let's remove these items. Then let's go back to add a product and there should be no items in the cart. Okay, so this brings us to the end of the tutorial. Be sure to like this video and share, and also hit the subscribe button for future tutorials demonstrating how to build full stack applications with Dart and Flutter. And on that note, I'll see you in the next one. Thank you.